In this short tutorial video we will discuss array block. Generally speaking, array is systematic arrangement of similar objects, usually arranged in row and column pattern. In conventional programming, programmer has to populate array, and index through array programmatically. IMAC array block eliminates all the complexities of array programming and indexing. Array block allows user to create state machine, and automate sequencing through elements of array as coordinate points, and I/O states. In this example, I will show how array block can be used in the applications like pick-and-place assembly, pipetting in lab automation, and others. I am going to block palette and selecting variable category. From here, I am selecting and dropping array and end array blocks onto the programming workspace. Array blocks have three fields: ID, array name, and name of array element. IDs of array and end array blocks have to match, and serve only for purpose of identification. Numeric or alphanumeric characters can be used. I am entering one into both ID fields of array and end array blocks. Array name is a descriptor used by the IMAC. Numeric or alphanumeric characters can be used. In this demo we will call array as points, as in plural. Element field is name of the element in the array. In this demo we will call it point, as in singular. To create array, I am clicking on Edit Array button, and Array Editor opens. I would describe array as a table which has rows and columns. Each row of the table is an element of the array. Columns contain properties of the elements. In our example, columns contain coordinates of x and y positions, states of the outputs, and time duration these outputs will stay on. Let's add required number of columns and name them. We will call first two columns x and y and populate them with xy coordinates. Table will move to. Next three columns will contain states of three outputs that we logically call sol1, sol2 and sol3. Each of these outputs has two states, 0 or 1. State value 0 will turn solenoid off, state value 1 will turn solenoid on. The remaining three columns will contain duration time, in milliseconds. Each output will be turned on. I want to make one comment here. The names we are using are just logical names, will be used later in the sequence program as parameters, as I will show in couple minutes. In this example we will create array 3x3, with 9 points. Let's start to create points. In first row, coordinates of x and y are zeros. And all solenoid are turned off. Let's create next point. XY stage will move to coordinates x equals 500,000 microsteps, y equals 0. Solenoid 1 will be on for 1 second programmed in milliseconds. Solenoid 2 and 3 will be off. I am adding the third point. XY stage will move to coordinates x equals 1 million microsteps, y equals 0. Solenoid 1 will be off. Solenoid 2 will be on for 1 second. Solenoid 3 will be off. Now let's make a motion in y-axis by entering next point with coordinates x equals 1 million microsteps, y equals 500,000 microsteps. All solenoids will be on. Each one will be on for 1 second. Now XY table will continue moving in the opposite direction along x-axis. X equals 500,000 microsteps, y equals 500,000 microsteps. Solenoid 1 will be on for 1 second. Solenoid 2 in off. Solenoid 3 will be on for 1 second. I am filling the rest of the points. Now I have finished filling the table. I am saving the table by clicking on Save button. Let's configure drives now. I am selecting Mode and Profile blocks from Motion Palette, dragging and dropping them onto the programming workspace, placing them before Array block. In previous tutorials I talked about configuration of these blocks. Next step, I will move both axes to negative limits to establish coordinate system. I am selecting homing blocks from Motion Palette and dropping them onto the programming workspace. I am selecting negative limits as home positions for X and Y axes. Let's program moves now using parameters from the array. I am selecting move blocks and dropping them between array and array blocks for both X and Y axis. I am selecting move type as absolute for both axes. Positions to which axes will move to are programmed referencing properties of array elements as point.x and point.y, enclosed in square brackets. This is how we access array element properties as parameters in the program. I am entering point.x in square bracket for x-axis and point.y for y-axis. Next step is to program outputs. In our example we have 3 solenoids. Solenoid 1 and 2 are wired respectively to output 2 and 3 of axis number 0 on USB channel 0. Solenoid 3 is wired to output 3 of axis number 1 USB channel 0. I am selecting and dropping 2 set output blocks into the sequence to program solenoid 1. The first block will turn solenoid on, and the second block will turn solenoid off. I am selecting output 2. Entering output state as point.sol1. And selecting axis number 0 for the first block. I am selecting output 2. Entering output state as low. And selecting axis number 0 for the second block. Now I am selecting and dropping delay block after the first set output block to program the time duration solenoid 1 will be turned on. I am entering delay time as point.delay1 for solenoid 1. I will create user block which contains these 3 blocks. I discussed how to create user block in previous tutorial video. I am selecting the blocks and clicking on user block button. I am entering solenoid 1 in the first field and entering turn on in the second field. The block will have light green color. I will do the same for solenoid 2 and 3. Here I am selecting axis number 1 for solenoid 3. I will create user block from first 6 blocks and name it config. I forgot to select axis number 1 for y-axis. I am selecting it now. Now program is ready to be executed. I am clicking Run button. I programmed serpentine pattern for XY stage to execute. Any pattern can be programmed by the user. LEDs in this video show the states of the solenoids being turned on or off. Just to add one more comment. For large multi-dimensional array, Excel file can be imported to populate array. This completes our array tutorial.